Okay, this introduction says that along with getting pledges and donations, the groupies also sold t-shirts and hats with their emblem on them. One person bought 3 t-shirts and 2 hats and paid 24 bucks. Another person bought 5 t-shirts and then after returning 2 hats also paid $24. So the question is, what was the cost of 1 t-shirt? Well, let's go ahead and look at this. We have 2 people. So if we look at person 1 and we add on person 2, we know that together they spent $24. Or I'm sorry, they spent $24 a piece. So together they spent 48 bucks. So let's go ahead and look at what person 1 bought. Person 1 bought 3 shirts plus 2 hats. Person 2 bought 5 shirts, but he returned 2 hats, so we have to subtract the 2 hat value off of that. And again, together we know that that equaled $48. Well, let's go ahead and look at how many shirts they bought together. Together, it looks like they bought 8 shirts. How many hats? Well, technically, we balanced out our hats. He bought 2 hats, but he got rid of 2 hats. So we're going to cancel them out and realize that 8 shirts equals $48. So how much does 1 shirt equal? $6. So we know that 1 shirt is $6. Okay, next question. What was the cost of 1 hat? Well, kind of hard to see here because we canceled out those hats. So let's go back to person 1. Person 1 bought his 3 shirts plus his 2 hats, and we know that he just spent $24. So let's go ahead. Our shirts were $6 a piece plus our 2 hats is going to give us that 24. So he spent 18 bucks on his shirts, which means that he has $6 left over for his hats. So one of those hats then equals $3. Okay, so 1 hat equals 3. Hopefully you realize what we actually just did was we solved a system of equations. We found out that both of them spent $6 per shirt, both of them spent $3 per hat, except this guy decided to give up those hats and give them back. Okay, let's go ahead and look at this algebraically and see what we did. Our first guy, again, had 3 shirts, I'm going to call them T, plus 2 hats, and he spent $24. Our second guy had 5 t-shirts. He got rid of 2 hats, but he also paid $24. From here, we actually horizontally added this together, but look at this. If I drew a line here, put an addition sign here, this is actually just an addition problem that I can add my shirts together and say I had 8 t-shirts. I canceled out my hats. Those 8 t-shirts equal $48. So 1 t-shirt equaled the $6. Then I can go ahead and substitute that in like I did for my hat. And I could say 3 t-shirts of 6 plus the 2 of the hat equals 24. I'm going to get rid of those parentheses because I don't know why I put them in there. And I know that 1 hat equals $3. So strategy number 3 on how to solve a system of equations. We are going to actually combine these 2 equations instead of substituting, and we are going to eliminate one of those variables. Remember, we cannot solve an equation with 2 variables. So what we did was we combined them, and by doing that, we eliminated it. And this is called using addition and subtraction. We are going to eliminate, so elimination. And with that in mind, go ahead and get out the notes and vocab for this section. Okay, objective of this section is to solve a system of linear equations, which is what we've done the last 2 sections, but now we're using elimination. So again, we're going to use addition or subtraction. The steps here that we're going to do, first off, write the system so the like terms with the same or opposite coefficients are aligned. So here's our coefficients. If you remember, coefficients are the numbers outside the variable. Remember, same or opposite sign. So look here, we have everything set up correctly. Our x's are aligned, our y's are aligned, our constants are aligned. So step 1 is done. Step 2, it says now we're supposed to add or subtract the equations, eliminating one of those variables. So really what we have to do here is we just have to go back to first grade and horizontally add these two numbers together, understanding that we're just going to add straight down. So 4x plus 3x is 7x. 6y plus a negative 6y is nothing. It's a 0, and I'm not even going to write it down. So I know that my 7x equals 35. Then I'm supposed to solve that equation. So solving that, I know that x equals 5. Again, halfway done. I know that those two linear equations share that value, x equals 5. Now I have to substitute that value in to one of those equations to solve for what y equals. So doesn't matter which equation. If you want to be consistent, throw it into the first equation always. But I'm going to plug that 5 in there. So 4 times that 5 plus the 6y equals 32. And now just go through the steps of solving for y. Substituting, adding and subtracting, multiplying and dividing. Okay, not quite done, because final answer then is that they share the point 5, 2. If we graphed it, that's where they would intersect. Okay, pretty straightforward and simple. All we have to do is understand we are combining those two equations together, and by combining them, we actually eliminated a variable. So with that in mind, go ahead and do guided practice 1. Okay, 1a is pretty straightforward. We eliminated the x variable by adding those two together, finding out that they share the value of 0, -1. Remember, getting down to this, don't let that 0 scare you. Sometimes we will have 0 as our solution. 1b, we had to go way back to step 1 on all of our steps and make sure that everything was aligned. This is not aligned. So I aligned my x's, I aligned my y's. That way, when I did finally add them together, y's were eliminated. Use that x value to substitute in and solve for my y. So the point that they share is 6, 1. Okay, moving on to example 2, it says we can use elimination to find specific numbers that are described as being related to each other. So this is going back to translating. We know -3 times one number plus 5 times another number is -11. We know 3 times the first number plus 7 times the other number is -1. We're supposed to find these numbers. So looks like we're going to have to translate -3 times a number. We don't know that number. Let's give him the value of x. Plus 5 times another number, let's call him y, is -11. Next one, 3 times that first number plus 7 times the other number is -1. Now they say we're supposed to find these numbers, aka solve the system of equations. So I'm going to go ahead and rewrite those down here so I have room to work. And then I'm going to realize that they are aligned. I can go ahead and combine these two equations, and by doing that I eliminate my x variable. I end up with 12y, be able to count here, equals -12, which means that y equals -1. So that second number is -1. With that information, I'm going to use that, substitute that -1 in for here. So I have -3x plus 5 times that -1. And I'm going to go ahead and go through my steps of solving for x. Adding and subtracting over, multiplying and dividing. So the two numbers are 2 and -1. Let me change my color. The numbers are 2 and negative 1. Good review of translating from words to symbols. With that in mind, try guided practice number 2. Okay, x plus y equals negative 10. Negative 3x minus y equals 2. With that, we eliminate the y's, find out x is 4, first number is 4, substitute that in, and find out that second number is negative 14. Okay, moving on to 2. It says sometimes we can eliminate a variable by subtracting one equation from the other. So here these were very nice because one was already the opposite. They eliminated right away. Sometimes we have to distribute a negative through all the values of an equation in order to eliminate one of those problems. So let's go ahead and look at this standardized test example. We're supposed to solve this system of equations. Well, first off, I noticed that my r's and my t's are not aligned, so I'm going to rewrite them. 2t plus 5r equals 6, and 2t plus 9r equals 22. Okay, very close to almost being able to eliminate, but notice that these are both positive. These are not opposite coefficients. So what I'm going to have to do is I'm going to have to look at this and distribute a negative through that second equation. So I'm going to end up with still the same linear equation on top. Second equation, though, is now a negative 2t minus a 9r equals a negative 22. Remember, I did not change any of the values of that because I kept everything balanced. I made sure to do that same operation all the way through. So now it looks like I can go ahead and solve this system of equations. Now I can go ahead and add them together. My t's cancel. I'm left with negative 4r equals negative 16. So r equals 4. Okay. With that, notice I have quite a few different options. So I'm just going to go with the safe option of taking that 4 and just plugging it in to this top equation. So I have 2t plus 5 times 4 equals 6. And then we know the drill. So it looks like my second term then is a negative 7. Okay, sorry, I was trying to look ahead to see what the answer is. So the values, they don't tell us what is x or y, but we know that one value is 4, one value is negative 7. So the system, the point they share is the point 4, negative 7. So again, sometimes we have to distribute a negative through in order to eliminate. Go ahead and try guided practice number 3. Okay, for this one, our terms were lined up, but again, realizing that they were all positive terms. So distributing that negative through, keeping still everything balanced because I did the same operation to all 3. I eliminated my b in order to find my c, substituted the c in order to find my b. Okay, so again, this is the subtracting. Technically, subtracting is distributing a negative through all variables and all constants. Okay, last example, we have another shot at some real-world story problems. It says Cheryl and Jackie work at an ice cream shop. Cheryl earns $8.50 per hour and Jackie earns $7.50 per hour. During that typical week, Cheryl and Jackie earn $299.50 together. One week, though, Jackie doubles her work hours and the girls earn $412 together. So the question is, how many hours does each girl work during a typical week? Well, let's go back and again do this in chunks. The first one we see is that Cheryl earns $8.50 per hour, Jackie earns $7.50, and they earned in that week $299 together. So $8.50 for Cheryl plus $7.50 for Jackie gave us $299.50 together. Looking at this next one, it says Jackie doubles her work hours and they earn $412 together. So we know they earn $412 together. It doesn't say anything about Cheryl. So Cheryl still worked the same amount of hours, but Jackie doubled hers. So we're going to say that with Jackie doubling, that's going to be 750 times 2. So it looks like she actually is getting 15 times her day. Okay, now how many hours does each girl work during a typical week? Looks like we can go ahead and set these equal to each other and solve. The only problem is, look at this. Cheryl did earn the same amount each time, but we need to have an opposite on there. So before I do anything, looks like we're going to have to distribute a negative through all of these. So in order to do that, I'm going to set up two final equations over here. We have 8.5c, I'm going to get rid of that 0, plus 7.5j equals 299.5. Negative 850c minus 15j equals a negative 412. And now we can go ahead and solve this, because look at this. We get rid of Cheryl. We'll go ahead and focus on Jackie. We do have a negative here, which is fine, because when we set our 299.50 minus 412 equal to each other, we end up with a negative 112.50. When we divide that by the negative 750, we end up with 15. So Jackie works 15 hours. Okay, knowing that, let's go ahead and plug in that 15 hours for Jackie. And let's figure out how much Cheryl worked. So we have 850 for Cheryl plus the 750 per hour. And we know that she worked 15 hours. We know that that's 299.50. 750 times her 15. So Jackie ended up getting $112 of that $299.50. If we subtract that from the $299.50, whoops, Cheryl then received 187 of those dollars. Well, dividing that by 8.5, it looks like she ended up working 22 hours. Okay, translating, what is it that we know? How are we going to use that to set up equations and solve? So final answer, we are going to say, how do you spell Jackie? Jackie worked 15 hours and Cheryl worked 22 hours. Okay, looking up here, when we see that 15J, that doesn't mean that she's getting double the amount of money. That just means that she worked double the hours. Okay, so this week she's actually getting paid double what she got there because she doubled her hours. So that's what that 15 means. Okay, with all of that in mind in your head, go ahead and try this last guided practice. Okay, two equations here. Tamra invited 5 fewer friends than Adelina. So Tamra is Adelina minus 5 friends. Together, there's our clue word for our second equation. They invited 47 guests. So Tamra and Adelina equal our 47. Now, again, with this being the third strategy of how to solve these, I saw right away that this is actually solved for T. So instead of solving for elimination, I'm going to substitute. So I substituted a minus 5 in for T. So I have a minus 5 plus this a equals 47. With that, I found out that Annalena invited 26 guests. Then I know that Tamara had 5 fewer guests, so Tamara invited 21 friends. So kind of think about that. Which strategy is going to work the best? And we do have one more strategy involved. So don't force elimination out of all of these problems. If there's a better way, go for it. With that in mind, go ahead and work on the assignment for this section.